Hey class, this is Mr. Roberts at Shasta High School. Tomorrow, Math 1 will be taking the fourth test of the term. Chapter 4, it's a quick little test, and I've kind of spelled out my expectations here. You're going to see me writing down some of the formulas that some of them I think you need to have memorized. Some of them you need to be able to work through and kind of reconstruct if you need them. Um, the first several questions, the first four, tell you that the following sequences are either arithmetic or geometric, right? It says identify each sequence as arithmetic or geometric. Because I didn't say or as neither, right? Arithmetic, geometric, or neither, you may assume that if I say identify them as either or, right, it will be one of the two. So no tricks here. So the sequences will be either arithmetic or geometric. And then for each sequence, state the common difference and state the common or the common ratio. So two things. You need to tell me, is it either arithmetic or is it geometric? And then once you do that, you need to give the common difference, and that either involves giving me the value of D or the value of R, the common ratio. So for this first one, as I look at them, I mean, I'm just gonna. It's either gonna be one or the other. So I'm gonna take the 14 and subtract 11, and that's a difference of 3, right? 8 or 11 minus 8 is a difference of 3. 8 minus 5 has a difference of 3, and 5 minus 2 is a difference of 3. So every single one of these are increasing by 3, right? Notice I kind of checked it going backwards by using subtraction, but in each case, 14 minus 11 was 3. 11 minus 8 was 3. 8 minus 5 was 3. And finally, 5 minus 2 is 3. So I see that clearly this has it's an arithmetic sequence, and it has a common difference of 3. So my answer would just be arithmetic and common difference, and I'll just use the variable D equals the value 3. Next sequence. We've got some negative numbers here. So, as I look at these numbers, these are definitely, they have bigger gaps between them, right? These are only 3 apart. These are 6 apart. Those are 12 apart, and those are 24 apart. So I can tell just based on the gaps, this is not arithmetic. It's got to be geometric then. So I'm going to take a look at the common ratio. So let's look at negative 48 over the one next to it, which is 24. When I take 48 divided by 24, I get the number negative 2. Let's look at the next one, right? 24 divided by negative 12, that equals negative 2. The next one, I've got negative 12 over positive 6. That ratio equals negative 2. The next one, I've got 6 divided by negative 3, and that common ratio is negative 2. I think it's cool, the negative patterns going, alternating between numerator and denominator. When I'm done, I can see, hey, this is clearly being multiplied by negative 2 each time. That's why I've got this alternating plus minus thing going on. And my common ratio is the number negative 2. So this is geometric, geometric. And my common ratio, R, is the number negative 2. That's 2 answers done. Next, let's look at number 3. Boy, these fractions make life interesting, don't they? When I look at this, right, 1 divided by 3, 1 over 3, it's clearly 1/3. And if I look at the next one, right, the next one's right here, 1/3 over 1, 1/3 divided by 1, that's clearly also 1/3. The next one, I'm going to take the 1/9, 1/9 divided by 1/3. If I have a fraction divided by a fraction, of course I can transform that. This is 1/9 times 3 over 1, which is 3 over 9, which reduces to 1/3. So in each case, I'm getting 1/3, 1/3, 1/3. I'm going to do the last one. 1 over 27, and I'm going to divide that by 1/9. That's the same as 1 over 27 times 9 over 1, which is clearly 9/27, which reduces to 1/3. So again, 1/3. And, let me just take a look at this with the scientific calculator, right? If you want to evaluate one of these, I can take, for example, the last term in the sequence, 1 divided by 27. Oops, 1 divided by 27. And I can press enter. And I wanted to divide that by, and I better use parentheses here, I think. I'm going to divide that by 1/9. 1 divided by 9. And when I do, I get this thing, right? Now, I believe I can turn this into a fraction pretty easily by hitting math and then pressing the button that says frac. That's short for fraction. Math frac, and it gives me the 1/3. So indeed, when I take 1/27 and divide it by 1/9, I do get the 1/3. So this is a geometric sequence. Every single time I move forward, I'm multiplying by 1/3. So I'll write geometric with my common ratio being positive 1/3. Last question I have here, again, same thing. Is it geometric or is it arithmetic? If I look at this, I can see that this is increased by 0.5, right? This is increased by 0.5. This one's increased by 0.5. And if I do the subtraction, right, 0.40 minus 0.35 is 0.5, 0.35 minus 0.30 is 0.5, and 0.3 minus 0.25 is 0.5. So this is a clearly an arithmetic sequence. And my common difference is 1/2 each time I'm increasing by 1/2. No, that's not 1/2. And it's actually, that's terrible. I see the 0.5, it's not increasing by 0.5 at all. It's increasing by point. Wow, good thing, just, writing these things out, I just kind of caught myself here. Probably, to avoid doing what I just did, it might be worth it to write, 0.40 minus 0.35, right? That's this term minus the one before it. Then I might take the 0.35 and subtract the 0.30 like this. Then I might take the 0.30 and subtract from that 0.25, and that's this difference right here. And I made a mistake. I just totally just call that 0.5, and it's not 0.5. I believe it's 0.05. So if I take the 0.4 and I subtract 0.35, oops, 0.35, I get a difference of 0.05. Yeah, if I take 0.35 and I subtract from that 0.3, clearly it's 0.05. So my common difference is 0.05, and I almost made a terrible mistake, but caught myself. So this is arithmetic, and the common difference is D is 0.05. So notice how we did this, right? In all cases, to find the common ratio or the common difference, I'm taking a term, and in the case of a common difference, I'm subtracting the one before it. In the case of a common ratio, like for this geometric sequence, I'm taking a term and I'm dividing it by the one before it. And that reveals that common ratio. And it's probably a good idea to do it with several of the values, just to verify that you're getting the right thing. If you make a mistake on one, then maybe you can slow down and figure out, hey, got to get the right common ratio, right common difference. Let's jump to question number 5.